Okay, so part B of 14.22 asks us to find the mass of our virus. So to do that, what we need to do is take the equation that we found in our last problem, and solve for mass of our virus. So what we're going to do is we're going to square both sides. So virus and then solve for the mass of the virus. So this one also just takes a lot of algebraic manipulations to make it work, and it gets a little tedious, but let's hit the ground running. So okay, so now what we can do from this point is factor out the mass of silicon. And we're going to want to do that at this stage because that's going to make our lives a lot easier in the next part when we have to plug everything in. So ouch. Okay, and now what we can do to get rid of this pesky little thing here, since 1 over something, we'll say 1 over x is just the inverse of x. So what we can do is just flip these two terms inside of this parentheses here, and then that will just become this whole term right here. So let's go ahead and do that. So silicon squared minus 1. Alright, so now we can go ahead and just plug these in from what we're given in the problem. It says that data shows that silicon has a mass of 2.1 times 10 to the negative 16 grams. So we can just plug that in, 2.1 times 10 to the negative 16 grams. And then we have the frequency of silicon, which in the problem it gives us as 2 times 10 to the 15th. So that's going to be 2 times 10 to the 15th over the frequency of silicon plus the virus, which we're given as 2.87 times 10 to the 14th minus squared minus 1. Alright, so we do all this math here. I don't have room to do it all in this board right here. So you do all that math, and that comes out to be (9.99) times 10 to the negative 15 grams. And we can pretty much just round this up to 10 times 10 to the 15 grams, which is, this another part of the problem asks us to give this in grams and femtograms, which a femtogram is just 1 times 10 to the negative 15 grams. So this will come out to be 10 femtograms.